So module 19 is address resolution. So address resolution is a protocol that is put into place so that when a device doesn't know a certain piece of information, it can send out a broadcast request asking for that information in order to complete the encapsulation process. Now, there are two primary addresses assigned to a device on an Ethernet LAN. Layer 2 physical MAC address used for NIC-to-NIC communications on the same Ethernet network, so again, handled by your switch. And then there is the Layer 3 logical address, the IP address, used to send the packet from the source device to the destination device. And your router is the one that uses that address. Now, Layer 2 addresses are used to deliver frames from one NIC to another NIC on the same network. So we're talking local area network communication. If a destination IP address is on the same network, the destination MAC address will be that of the destination device. So again, your switch will do what your switch does, and it will look to its MAC address table. It will see if it has that destination MAC in its table. If it does, it would simply push it out the port associated with that MAC address. But when the destination IP address is on a remote network, the destination MAC address is that of the default gateway. So ARP is used by IP4 to associate the IP address of a device with the MAC address of the device NIC. With ICMP v6, this is what IP6 will use to do this. To do the same process. So it's going to associate an IPv6 address of a device with the MAC address of the device NIC. So routers examine the destination IP4 address to determine the best path to forward the IP4 packet to. When the router receives the Ethernet frame, it de-encapsulates the layer 2 information to get to that address of the destination. Using the destination IP address, it determines the next hop device, and it then re-encapsulates it into the IP4 packet with a new data link frame for the outgoing interface, as well as a new trailer with a new CRC value. So a device uses this ARP to determine the destination MAC address of a local device when it knows its IP address. So ARP provides two basic functions: resolving IP4 addresses to MAC addresses and also maintaining an ARP table. This table is a mapping of an IP4 to a MAC address, as you see here in this picture. So command ARP-A on your PC will give you the information that your PC knows right now. Okay? On a router, it will be show ARP, and we would see the same type of thing, which is a mapping between an IP address and a physical address. So what I want you to think about, and I'd rather go over this in class, is why don't we know the MAC address of the destination, which for the first point would be from the source to the router? So why do you think that we would know the IP address of the default gateway, but not the MAC address of the default gateway? And I'll save that conversation for the classroom. So to send a frame, a device will search its ARP table for a destination IP address and that corresponding MAC address. If the packet's destination IP address is on the same network, again, the device will search the ARP table for the destination IP4 address. If the destination IP address is on a different network, the device now will search the ARP table for the IP address of that default gateway. If it is located, its corresponding MAC address is used as the destination MAC in the frame. If there is, however, no ARP table entry, Then your device will send out an ARP request. So it'll go out as a broadcast. So again, thinking in the MAC addressing, a broadcast in the MAC addressing is all Fs that correlates to all ones. All ones mean a broadcast. So it goes out, and pretty much within the message it says, hey, I have this IP4 address. I'm looking for its MAC address. Whoever owns this IP4 address, could you please tell me your MAC address? So that's pretty much in layman's terms what that message is within that broadcast or that ARP request. Only one device on the LAN will have an IP4 address that will match the target IP address in the ARP request. All of the devices will not reply. So if no device does respond to the ARP request, meaning I can't bind this to any MAC address, then two things happen. Encapsulation cannot continue and be complete, and therefore the packet is dropped. So in both cases, the search is for an IP4 address and a corresponding MAC address for the device. Each entry or row of the MAC table binds an IP4 address with an associated MAC address. We call the relationship between the two values a map or a mapping. Now, entries in that ARP table are not permanent, and they are removed when an ARP cache timer expires after a specified period of time. And the particular duration of that ARP cache timer depends on the operating system. As an example, Windows is 15 to 45 seconds. So ARP table entries can also be removed manually by the administrator. Okay, so after an entry has been removed, however, the process for sending an ARP request and receiving a reply must occur again to enter the map in the ARP table if the destination is for the mapping that was removed by that table. So we can go in there and we can remove these things manually, although it is not suggested to do so, but do know that you do have that option. So the show IP ARP command displays the ARP table on a Cisco router. And again, what you see is an IP address bound to a MAC address, and specifically to interface G000. On a PC, again, remembering when we're looking at these things, we want to know from whose perspective we are looking. So on the first case, we are looking from the perspective of the router. Okay, it says so right here, R1. In the second example, we are looking from the perspective of the PC. We know this because we are in the C root drive. So when you're doing your troubleshooting, it is very important for you to understand which one you're looking at. A lot of you on the last lab that we did, I'm having an issue talking today. The last lab that we did, a lot of you were confused with regard to who was or what window was the PC and what window was the device. Okay, so don't let that confuse you. In your labs, it's easy to differentiate between the two. Here I have two black screens with white writing. In your labs, we made it so that your devices have a blue terminal and your PCs have that command prompt black terminal. So in the lab, it's very easy to differentiate. When you're looking at two things that look identical, look to whom's perspective you are looking from. That will identify either a network device, in this case R1, or a PC. Now, ARP requests are received and processed by every single device. So what we've learned so far about broadcasting, not the best policy in place, correct? Because the fact that everyone has to receive it, everyone has to process it, but only the one that matches that IP address will actually answer the request. So excessive ARP broadcast can cause some reduction in performance. ARP replies can also be spoofed by a threat actor to perform an ARP poisoning attack. This is a form of attack in which An attacker changes the MAC address and attacks an Ethernet LAN by changing the target computer's ARP cache with a forged ARP request and reply packet. ARP spoofing is also a type of attack in which a malicious actor sends falsified ARPs or ARP messages over a local area network. This will result in the linking of an attacker's MAC address with the IP address of a legitimate computer or server on your network. Enterprise-level switches include mitigation techniques to protect against those types of attacks. But, again, identifying reasons why ARP is not good, because it is based on broadcasting. Broadcasting is a waste of your device's resources, okay? It gives you latency, reduction in performance, leaves you open to different types of attack. And so in IP6, you won't see ARP being used. You'll see something like network discovery and things of that nature, and the use of ICMPv6. And we'll talk about that in a little bit. Oh, and here's a little bit. So IPv6 neighbor discovery, ND or NDP. It does the same function as ARP IP4. So ND provides an address resolution, router discovery, and redirection services for IPv6 using ICMPv6, Internet Control Messaging Protocol. So ICMP version 6 ND uses 5 different messages to perform these services. A neighbor solicitation, identified as an NS, and a neighbor advertisement. So these messages are used for device-to-device messaging, such as address resolution. So this is very similar to ARP in IP4. ICMPv6, router solicitation, and router advertisement, these are used for messages between your devices and routers for router discovery. So we haven't really talked about IPv6 yet. We'll do that in Module 12. But IPv6, how it discovers information about devices is done differently. How you get your dynamic host control addressing is done slightly differently. And this is because when they revamped and upgraded from IPv4 to IPv6, they put in more controls and things of that nature that handle operations so that we don't need another outside protocol in order to do functionality. Now, ICMPv6 redirect messages are used by your routers for better next hop selection. So IPv6 devices use, again, ND network discovery to resolve that MAC address of a known IPv6 address. Similar, again, to ARP requests and ARP replies used by IP4. Your neighbor solicitation messages are sent using special Ethernet and IPv6 multicast addressing. So here you see a little improvement here. So in ARP, we were using broadcasting, which we know we can have a broadcast storm, take down your network, we can let in threat actors. So, excuse me, here neighbor solicitations are done with multicast addresses. So this allows the Ethernet NIC of the receiving device to determine whether the neighbor solicitation message is for itself without having to send it to the operating system for processing. So that was a real quick snippet of the ARP request and ARP reply in the ARP protocol. It is a very simplistic protocol. It is simply used to bind a MAC address to an IP address. And so when we visit this in the classroom, if you have any questions at that point, please be sure to bring them to the table. Thank you.